Uh, Hello everyone, hope you are doing fine. My name is Peter Sohoga and I'm going to be taking you through a turning effect of force. This is a lesson for S.2 physics and we are going to go through together. Hope you enjoy. After this lesson, we expect a learner to be able to define the term moments or to define the term turning effects of force. And the learner should understand the factors that affect the turning effect of force. The learner should know the different examples, the real life examples of the turning effect of force. And you should also perform calculations on moments using the formula that we're going to see as we proceed in our lesson, which is force times distance, FD. To start with, we'll start with a definition. I will define moment as the turning effect of force about pivot, but preferably we will define it as the product of the force and the perpendicular distance from the line of action of that force to the pivot. We may need to visualize what the perpendicular distance from a line of action means. Takes us to our next slide. Now, as you see in this diagram here, we have point O as our pivot point, and there is a distance from O to where F is acting downwards. That distance is a perpendicular distance from the pivot. We call it perpendicular because that distance should be making 90 degrees with the line of action of the force. Now, the red arrow on our diagram is representing the line of action of the force. So between the red arrow and this black arrow, which shows the distance d, there is 90 degrees. So that's why we call it perpendicular distance. So from the definition, we get our formula that moment of force is force times distance from the pivot, which we can abbreviate as moment M is equal to Fd, where F denotes the force and D denotes the perpendicular distance. As we have defined and we have seen in the diagram, we have got two factors that affect the moment of force. We have one is the magnitude, the other is the distance from the pivot. How do they do this? We're going to visit this link and we do some practical experience and we see how do these factors affect the turning effect or the moment of the force. So join me as we go for this illustration. Here we are using FET and this is it. As you see, our ruler now is balanced. The ruler is balanced and that's why you see our levels are green. Now, to see how mass or force affects moment of the force, we are going to put two masses of different magnitude at the same distances. So 5 is at 1.5, even the 10 is at 1.5. Now you realize that they have the same distances, but when the mass changes, you realize that a bigger mass, which means a bigger force, gives us a bigger moment. That's why you see that the turning effect of the 10 kilograms is more compared to that of 5. That's why you are seeing the, the ruler is bending towards where we have the 10, and it's going up where we have the 5. So when we change and we use 5 at the same distance, you realize that our ruler is going to balance again. That's why you are seeing the green light is now on. So when it balances again, it shows that when we increase the force, the moment also increases. Now we can try with distance. What happens if I alter distances? Maybe I use the same mass, which is 5 kilograms, and I bring it to a smaller distance. Now you realize that a bigger distance will give us a bigger moment compared to a smaller distance. Whereas if I bring them to be at the same distances, then our ruler will balance again. So this to our brings us back to our slide here. Here we have said that a larger force will produce a greater turning effect, making the object rotate faster or with more force. So we have seen that when we put the 10 and the distance, when we increase distance, then the turning effect also increases. So those are the two factors that will affect our moment of the force. Now we have examples that we can use. We can see these moments being applied in our daily life. The first one is a seesaw. We can see it most in nursery schools where we see kids playing from some kids the other side, other kids this side. We have a spanner. Mechanics use it a lot during their work. Opening doors. This one, each one of us does it daily. Open either a door, either a window, you close something. That is one of the applications. Pedaling a bike, opening a tap, using a hand hoe in agriculture, and lifting a cow with a jack. All these ones are applications, but we can see some of them one by one. If you look at a seesaw, uh, you see the boys and girls playing. So you realize that this boy is up, and from what we have seen about the factors, it may be that this girl, or you see the girls, these two girls, are applying a bigger force compared to him. So one girl might even be applying a bigger force more than the boy. That's why you see him up. Uh, the other thing is a spanner. So you see it is either used to open or close a nut or a bolt. And as you use it to open, there is a turning effect because the ease in opening or closing varies on which force you use or at what distance are you holding the spanner. You realize that a person who is using a who is holding it at the end will find it easier than a person who is holding it nearer. Opening a door, the reason why we have door locks or openers at the end of the door from the hinges is because we want to increase the distance to make the turning effect bigger, such that it is easier for us to open or to close. Pedaling a bike, that's why the pedals are put at the end of that axle, such that the force that you put there and this greater distance can give us a good turning effect in the tires so that we can have ease while pedaling a bike. So after looking at those few examples, we can hint about how we can calculate moments, and we are going to be following 3 steps. You identify the force and the perpendicular distance from the pivot. You substitute the values in this formula. Moment is equal to force times distance, and then you calculate the moment m, and the units will be Newton meters. Now, sometimes they might give you the moment, they ask you the force. You just need to identify what you have been given. You substitute what you have been given in the formula, and then you get the answer finally. These are some of our numerical questions. You can try them out if you get time. We'll be sharing this on our YouTube channel. You will follow and do all those exercises that are there. Otherwise, thank you for listening to me. We meet again in the next lesson. Have a good time.